Hi folks, this is an electric fly swatter or racket zapper made for killing flies, but it also makes for a very cheap, though limited, high voltage power supply. Here it's powering a Franklin's bell. And if you just want to make some sparks, it does that too. You can find them in stores like Walmart, Home Depot, Maplin, and many others for under $8 or €4, and also online. This one uses two AA batteries. It has a switch on the side that you have to hold pressed for the high voltage. Here's a close-up of the high voltage side. It's made up of 3 meshes. An outer mesh here, a middle one with smaller holes, and another outer one for the other side. Here I connect to the 2 outer ones. When I turn it on, there's clearly no spark. That's because the 2 outer meshes are electrically connected together. The high voltage exists only between the outer ones and the middle one. To prove that, I wrap some non-conductive tape around most of the end of an alligator clip. That's so that I can clip to the middle mesh without electrically connecting to the outer mesh. The other wire is still connected to the other outer mesh. Either one will do. This time I get sparks. And here I've set up a Franklin's bell. In the middle of the 2 cans is a ball of kitchen aluminum foil. I couldn't get it to work with the soda can top though. It seems to need something rounder, but there wasn't much else I could get working with it. There wasn't enough current to ionize enough air for my ion wind rotor, and also not enough current for my big Corona motor. And I know it wouldn't work with a lifter or a smoke precipitator, so I didn't even try those. Here I've set up my oscilloscope and Fluke 80K-40 high voltage probe for measuring the voltage. You can see it's relatively low, only around 1400 volts. And finally, time to open it up and see what's inside. I even pry apart the racket section to see where the wires go to the 3 meshes. One outer mesh is connected to the circuit via this yellow wire, the middle mesh is connected via this red wire, and the other outer mesh is connected via this other yellow wire. And looking more closely at the circuit board, we can confirm that the 2 outer meshes are electrically connected together, right here where the 2 yellow wires go to the same place. I then unscrew the circuit board. You can see where the positive of the batteries goes to the switch and from there to the board, while the negative of the batteries goes directly to the board. And for those really curious, here's the schematic I made from analyzing it. It's almost the same circuit as this Joule thief circuit I used to power this compact fluorescent light bulb. There's just an LED and current limiting resistor added to tell you when it's turned on, and on the output there's a diode to turn the output into DC, and a capacitor for smoothing. There's also a bleed resistor to get rid of the high voltage when it's turned off, plus another resistor right here. But other than the LED and the modification to the output, they're both the same blocking oscillator circuit. And that's the electric fly swatter, or Zapper Racket. Well, thanks for watching. See my YouTube channel, rimstar.org, for more neat videos like this. That includes one all about the Franklin's bell that I demonstrated, another on making a more powerful 30 kilovolt high voltage power supply, and one all about my compact fluorescent light bulb powered by the Joule thief circuit. And don't forget to subscribe if you like these videos, or give a thumbs up, share with your social media, or leave a question or comment below. See you soon!